If you want to learn how to make a top-down dungeon crawler, something inspired by classics like Gauntlet and even Diablo, something that has pathfinding enemies and area of effect explosions, something that was the beginning of my own dungeon crawler game, a top-down, couch co-op, action RPG with randomly generated levels and multiple player characters, then keep watching and I'll show you how.
G'day gamers, and welcome back to our top-down dungeon tutorial. In the last episode, we added the ability for the enemies to follow the player, but now we need to add the animations. So the first thing I'm going to add is just an easy game restart option, which will just enable us to test the game a little easier. Let's go into our game. I'm just going to add an event. It's a key pressed event for the letter R. And in here, we'll just type game_restart. So now we'll just press R and we'll get the game to restart. It'll be handy for when we're testing things. Now in the last tutorial, we loaded our enemy sprites. So we have the idle, the walk, the attack, the dead, and the hurt. But now we need to code the enemy so they know when to use these sprites. And these different sprites are essentially different states that the enemy can be in. And I like to use these animations as a framework for a state machine. Now, a state machine allows us to set an object to a particular state, and this then limits what code can be run while in that state. For example, as humans, if we are in a sit state, we can't move. So the option to move is not available while in that state. To move from a sitting state, we first need to go to a standing state. And once we're in a standing state, we can then go to a moving state. So it's the same thing with our enemies. We can set them up using states, and that way we can limit the code that's going to run. It makes enemies much easier to control. And we can also just assign the appropriate sprites while they're in that state, and the animation part is then easily taken care of. First, I want to create the states we will use, and I'm going to use enums to create the states. Now an enum or enumerator is just a list of constants, which Gamemaker will convert to sequential numbers starting at 0 when it compiles the game. But for humans, it's easier for us to remember the names of things rather than the number, so they're very handy to make your code a lot clearer to understand. Now I'm going to call our enum states, and this will be the list of states our entities can be in. So just in our game again, in the create event, I'm going to create the states here. So just at the top, I'm going to say enum states, and then we write the states that we want to have. Now, I like to write my enums in capitals. So I like to write idle. I'm going to have move. We want to have an attack state and also a dead state. Now, you notice that they turn red, indicating they've been identified as valid enums, and there's a comma just between them. Now, as I mentioned, we write them as words, but Gamemaker will convert this to 0, this to 1, this to 2, 3, and so on. And we reference these by writing the enum name and then a period and then the enum value. So for example, if we have states.idle, then we're talking about this entry. So now we have to find our enums. We can assign one of them to a variable for the enemy, but I want to use these for the player too. So let's make an oEntityParent object, which will be a parent for the player and the enemy parent. And that means that any variables that they all use, we can just create them once in this parent object. So under entity, let's go and create a new object, and we're going to call it oEntityParent, or PAR for short. Now, if we go into here, we can go to the parent section, and we want to drag the enemy parent across and also the player across. Now, they are children of this entity parent. So let's add a create event here. And now in here, we can have the variable that holds what state we are in. And I'm going to call it state. Now we access the enum by writing the enum name and then the name of the enum entry. So I'm going to start with the idle state. Now when you create an event in a parent event, a thing to note is that it'll overwrite the child event unless you inherit that too. So in the player's create event, we'll notice that this event will be overwritten because the player has a parent entity and that has a create event, so it'll overwrite the player's create event. And how you can avoid that though is just say you want to have event inherited. And then this will enable it to run the parent event and then run the child event as well. So we'll just take a copy of that line and then we'll go to the parent of the enemies. And in here, for the create event, we'll put that up the top as well. So now we've established a state variable for all of the entities. We can go to the step event for the enemy. And you'll notice that we have a step event already for the enemy parent, but I want to add a switch statement, which will look at the state variable and only run the code for that state. Now we could add this to the enemy parent. We could just add this here, but that would mean that all other enemies would run the same states, and that might not be what you want. So that's something you'll have to decide based on your needs. So for now, let's cut the step event out. And let's go to our enemy. And let's paste it in here. So now we have the event pasted here. And what we can do is add the various states that we need this enemy to be in. So I'm going to use a switch statement. And a switch statement will let us choose one option from multiple options. And the options are called cases. So the first case is just states.idle. And basically we want to take this check for player and just put that in here. And now at the end of the case, we just want to add a break, and that will mean that's the end of that case. So I'm going to select all of this and just press Ctrl D, and we'll duplicate that, and then we'll have the next one being a move state. Now for our next one, we want just case states.attack. Now the great thing as well about enums is they have predictive text. It'll show you the values that you can choose, and you can just hit enter to select one. So for our attack state, we don't really have anything yet, so we'll just leave that empty. And also we have a dead state. So the same thing, we'll just leave that one empty. So to clarify, the switch statement just ensures that each time the step event is run, only the code in one state is executed. Now, if you remember, in our player, in our step event for the player, we have an animation script or an anim script that controls the animation. So let's do the same thing for the enemy. Now let's go up to our scripts and we have a player processes. Let's create a enemy processes to hold that information. So the function we want to have is called enemy_anim, standing for our animation. Now, essentially, I want to have the same switch type statement. So I'm just going to go back here, go back to our step event for the enemy, and let's just take a copy of that and let's paste it in here. Now we don't need to run this or this, but we do need the states. So it's handy to have them here. And what we can do here is set the sprite index to be the sprite for the particular state. But because I want to use this enemy anim for multiple enemies, I don't want to set it directly to the sprites that we have for the enemy, because then all enemies would use those same sprites. Instead, what we can do is go to our enemy, go to our create event. So right here, I want to have a create event, even though this is in light gray, which means it's being inherited from the parent. I want to have one just for the enemy. So you can right click and you can inherit event, and that'll add the event inherited automatically. Now here, I want to assign the sprites for this enemy. And I'm just going to have a variable called s_idle and assign it to enemy idle. And then we want an s_walk. And we'll assign it to enemy walk. And we'll do the same thing for the attack. And the dead. And lastly, the hurt. Now we want to assign these to each enemy so they could all have their own sprite type. But by doing it like this, we can go back in here and we can simply say sprite index is equal to s_idle, and we'll copy that and paste it onto each line. But basically just change this to our walk, attack, we have our dead, and I'm not going to have one for hurt right now because we'll do the hurt sprite a little bit differently. Now we can't quite test this yet because we have no way of moving between our idle and our move state. And in order to move between these states, we need a condition to be true. We need to know, are we moving? If we're moving, then we'll go to the move state and we'll show that walking animation. And once we're in the move state, if we're not walking anymore, well, then we want to be put back to the idle state. For this type of check to happen, we need to know, are we moving? So we'll need to know, did we move this step? And we're going to have to find some other variables that'll help us work out if we moved. We also talked about last tutorial having the enemy face the player. At the moment, when the enemies are chasing us, they're not even looking at the player. So I'm going to deal with that first, and that'll lead in to then how we move between our states. In order to face the player, first thing I want to do is know what our position was the last step. And we'll use that to then set our facing direction. Now remember, when I say they, we're talking about our enemy for the moment. So there are variables in Gamemaker called xPrevious and yPrevious, and they will do just that. But they don't work in the step event, as they are updated between when the step event runs and when the collision event runs. So instead, we'll just create our own. So let's go into our enemy parent and then into our parent entity. And I'm going to create these here because we'll use these in the player and the enemy. And we're going to initialize our previous positions. I'm just going to call them XP and I'll set it to X, and YP and we'll set it to Y. And now we have these variables, we can just update them at the end of the step event. So inside the enemy once again, if we look at our step event, we can see that if we want to update those variables, what we can do is have our enemy anim script here. And we need to run this for every state. So let's just take a copy of that line and we'll just make sure that that's being run for every state. And since that's run for every state, we can just middle click on that and go across to our enemy admin function, and down the bottom, make sure you include it in the function itself. Let's update our position. So we want to update our previous position. And we can just do that by setting our XP to our current X and our YP to our current Y. So all this is doing is making sure that whatever our previous position was, we're storing that in our XP and our YP. And that'll be handy because then we can tell if we've actually moved, and we can also use it to find out which direction we're actually moving. Now, I mentioned in the last tutorial that the enemies need to face the player when moving, so we can easily do that now by adding that check into our move state only. So because we had this check for player script here, let's take all of this. So I'm going to close that, select it all, and just cut it out. And in our enemy processes, I'm just going to put it in here just to keep everything in one location. So we can close these down if you need to look at them elsewhere. And our check for player script, we don't need that anymore because basically we're going to put all our enemy checks in our enemy processes. You'll see the color will change, indicating that it's not a script name now, it's just the function name. Now, if you're in drag and drop though, because drag and drop is so long, you might not want to do this. You might just leave them as separate scripts. So whenever I create a new function, it just means for you to make a new script and make it just hold that function only, as DnD can just get quite lengthy. Now, if you recall, if we go over to the player and if we go to the draw event, we have our facing here. So we're using that facing to draw which way the player is facing. So we probably need to have this in the entity object too. So in our create event, where we're setting our facing, we can actually cut that out and we'll go to our entity and we'll paste it in here because the enemy is going to use it as well. So with the enemy now using that, let's go into our enemy processor script and let's add another function up here called check facing. And all we want this to do is just check which way we are moving and set facing accordingly. So we can just do that by saying var facing is equal to the sign of our current x position minus our x previous position. And if we're moving to the right, then facing is going to be 1. If we're moving to the left, then our facing is going to be -1. But if our position is the same, our facing will end up being 0. So we have to check and say if facing is not equal to 0, then facing is equal to underscore facing. So this is just a simple check that uses our x previous position just to calculate if we're moving to the right or to the left. So whichever way you're moving is the way we'll be facing. And let's add that to our move state. So back for our enemy. When we're moving, we want to check for facing. And we'll just paste it in here. Now, the only problem with this is that if we go to our draw event, the enemy is not actually using the facing variable like the player. So let's take the draw self out. And if I try to delete it, you'll see that it can't happen. And that's because this event is locked. It means that only in the parent is where you can edit this. So you can right click and open the parent event, and then you can delete it from here. So back in our player, let's grab our draw event, and that's this one here, and let's cut it out. And let's go to our entity parent and let's paste it in. So now this draw event will now work for the player and the enemies. So that way, if you want to change it, it only needs to be changed once in this place. Now, the other thing we need to do is just go to our enemy parent and just delete their draw event. Now it just creates the draw path. You don't need that anymore, so we can right click and delete that. Now in our enemy, the thing that I mentioned is that we can't move between these states. We have no way to move from idle to move, but we can do that, and we could do that using that XP variable. But there's also another way. We could also do it based on our path. If you remember, the enemy has a path they move along towards the player. And when they are no longer moving along a path, well, that's when they should be in their idle state. So how do we know they're moving along a path? Well, there's a variable called path index, and it's a value between 0 and 1. 0 is the start of your journey, and 1 is when you've reached the end of the path. But if this variable equals -1, that means that you don't have a path at all. So if the variable does not equal -1, that means you've been given a path, and if that's the case, then we want to move to our move state. So our state variable is going to equal states.move. Now let's take a copy of that and just paste it here. And if our path index does equal -1, that means we've reached the end of our path. We can go back to our idle state. Now let's test this out. I'm going to press play. And now the enemies are facing the right direction. They're in their walk state. And when they get to the player, they go to their idle state. So they're bouncing up and down. As soon as you move, they're walking, and they're also facing the right direction. So it's great. Looks like it's doing the right thing. Now, depending on the size of your enemies and the size of the masks, sometimes they may get stuck in the wall on the corner when they're trying to navigate around it. So I'm going to show you a fix for that if that applies to you. So let's fix that. So what we want to do is just go to our enemies and make sure that the origin position is at 16 and 26. I'm just going to lower it a bit. And then also I'm going to set the mask to just be a little lower. So the top is now down to 20. And remember, the idle sprite here, because we're setting the O enemy to use only this mask, we don't have to change the other masks. It's only this one that they're all using. But we do need to change the origin position of all the other sprites. So let's go into the walk and just make this 26. And the same for all of them. And by lowering the origin position in relation to the dimensions of the mask, it should avoid those getting stuck on the corner moments. And this should help because basically pathing doesn't take the mask into account, as it's just a position-to-position calculation. If we moved with no diagonal movement and our mask is small enough, we wouldn't get stuck at all. But it doesn't look good, so we can set it up so if we do get stuck, we can calculate a path that has no diagonal movement. And that should get us out of being stuck on any corners. So if we just go into our check for player, and just in here is where we're looking for the path to the player. So I'm just going to use our XP and our X variables to ensure that we don't get stuck. And we can say that if our X is equal to XP and our Y is equal to YP, then we haven't moved this step. And if that's the case, maybe we're actually stuck. So I'm going to say var type is equal to 0, else var type is equal to 1. Now 0 and 1 indicate that 1 will allow diagonal movement and 0 will not. Because if you remember, when we did our grid pathfinding, allowing diagonal movement is an option and it's either set at true or false, the same as 0 and 1. So we can change this choose and just set it to our type. And now if we're stuck, we go back to using non-diagonal movement and that'll hopefully remove us from any stuck on corner position. So let's press play and just test that out. And we weren't really getting stuck before, but you'll see that the positioning of the enemies is a little better in relation to the objects they're trying to move around. They overlap a little bit here, and it's just a little better how it's set out. Now, you will notice that the enemies do clump a lot when they come towards the player. And that's something I'll talk about at the end of the tutorial. For now, let's go ahead and add this new state system to our player as well. So let's go into our player and let's go into our step event. And at the moment, basically this is our idle state and our move state. This will cater for both. So let's create our switch statement and we'll do our switch state, not states. States is the enum. State is the variable holding which state we're in. Just make sure you don't confuse the two. State should come up as a blue instance variable, whereas states is coming up as a red enum. So we want to look at our state that we're currently in, and instead of setting the different states, we can just have a default state here. And default will just mean that if none of the states are found in the list under the switch, we'll just use this one. And the reason I'm doing that is it enables you to add states to the player. And if you don't need them to be a different state than the idle or the move state, they'll just use this one. It also introduces you to a new keyword, which is called default. It's actually pretty handy in relation to switch statements. So that's all we really need to do for the player. But setting it up like this will make it easy for our animations later on.
Now we still need to add the enemy death state, a damage system, a knockback, and health bars. So that's what we'll cover next episode. I mentioned earlier that I'd like to talk about how to avoid the clumping of enemies. Well, I sometimes add bonus content for Patreon members, so I'll be adding that feature over on the Patreon site. If you enjoy the content and would like to support the channel, you can contribute over on the site and get bonus features as well as early access to videos. This month, I have these generous Patreon members to thank. The amazing and supportive legendary Patreons are Keizo, Andy K, Chris Wheeler, Nal, and Big Honk. Thanks to these considerate epic supporters, Skydevil Palm, Edward Lyko, Paul R. LeBlanc, Robert Churches, Sinfuldiga, Sudo, Sapita, Yutomo Mitsu, Goldwind, Firis Al Harden, Katie Ratio 85, Chris LeBlanc, David P, and Sadface. Lastly, thank you very much to these rare Patreons. I appreciate your support as well. So thanks for joining me. I'll talk to you in the next one.